FYR, is that a year?
Yes.
What? Forced inertia and mass, where does year come in?
What is year a unit of?
Alright.
No, it's not gonna come in. The original problem had force, inertia, and mass, and then it also had some stuff from chapter 3.
Yeah.
So I kept all the answers that were possible and just took out the chapter 3 stuff for the master set. If you looked at the chapter 3 master set, you'll see a similar problem, except it's not gonna have force, inertia, and mass in it from the original test problem. And so I kept the same answers, or same choices, and just
Okay.
edited the left side. Yes, Anna?
Say if you only get one, and if there is multiple answers and you only like get one of them written down, will you only get partial credit for that? Or?
That is correct.
Is that for 12?
Pardon?
Are we talking about one for 12?
Talking about the multiple choice,
Right.
8 and potentially 9. I guess 9's not gonna have multiple, since I have either and neither as choices. I forgot what 12 was. Oh, is that the 4 forces acting on the box? Okay. And once again, bouncing on a scale, okay. Yeah, if there is more than one, that's another one. If there is more than one, then circle all the correct answers.
I wish I had a scale, I would have been able to demonstrate that one.
And my analog scale's at home right now.
Huh?
My analog scale's at home. Otherwise, I would have brought it out.
Okay.
All right, other questions? Hi, Chuck?
Not really about the actual work, but
Okay.
the last time to turn in the master set is it was picking up today.
Officially,
Okay.
if there's an extenuating circumstance. When I was in graduate school, my son was still in diapers. And my wife was out of town, so I was chief cook and bottle washer. And I thought, all right, I can finally get my homework done when he takes a nap. That was the first weekend he did not take a nap at all. So that's the kind of thing, an extenuating circumstance that where I have sympathy. That sometimes things come up at the last moment, even if you might have set aside the time to do it, stuff happens. Just remember how tired I was.
You did good.
Yeah. But he's a full-time job now. Yay! And his own insurance. Yay! Other questions? Yes?
If I was a friend in person, would it have to be the printed out version, or can I just like write down the answers?
If you just write down the answers, you're playing an all or nothing game.
Okay.
I mean, except, I guess, units could give you, if you have the right number, but the units aren't there, you get partial credit. But if you don't show any work, then there's no way for me to give partial credit. Yeah, I've survived many courses on partial credit, so I'm a believer in it, but I have to see the work. And yeah, I'm gonna say it. It's one of those things. If I tell myself I probably shouldn't say it, I probably shouldn't, but I'm gonna do it anyway. This is not directed at anyone in particular. No one has given me any reason to think that any of you would take a shortcut on this. If you're just writing down answers from someone else's sheet, the impact, you're basically screwing yourself for the test. So please make sure you understand. I have no problem if you're working with someone else. I do have a problem if you're writing answers down because you have no idea what's going on. and you're just putting something down. It's gonna hurt you in the long run. All right, so enough of that. Yes?
So like when you subtract or you add and stuff, you have to show that you subtracted on the paper.
I mean, there's certain, I mean, how, I think ultimately the question is how explicit do you need to be when you're writing your work?
Yeah.
There's certain things that, for example, this one, if I had 100 this way and 40 that way, and you wrote down 60, I think I have a pretty good idea that you subtracted. So, where do I draw the line? At what point is it what you did obvious, and at what point is it, I'm not quite sure what you did? It's a gray area. Sorry, I can't be more specific than that. By the end of the course, I'll understand some of your math abilities at that point, and at that point, I'm going, yeah, that person understands what's going on, so they can skip that step. That person hasn't really demonstrated that person knows how to do that, so that seems a little bit sketchy.
How do I convert the mass from newtons?
May I overblow my response?
What does that mean?
I'm gonna blow it way out of proportion, my response.
As long as it's logical.
As long as it's logical? Is that what you said?
Yeah.
Then I'll keep it tempered. You can't, it's not a conversion. You aren't converting from
Maybe I used-
kilograms to newtons or newtons to kilograms.
Maybe I used it wrong.
Conversion is what you're doing if you're talking about the same type of quantity. You can convert newtons and pounds because they're both units of force. Kilograms is a unit of mass, newtons is a unit of force, so it's not officially a conversion. So if I had something weighing 21 newtons on the moon and 21 newtons here, they have different masses, so it's not a conversion because you're not getting the same answer. Now, the formula you would use to find the mass, if you have the weight, is this one right here. That would be the relationship.
The weight is 21 newtons.
If the weight's 21 newtons and G depends on, I think you're on the moon for part of it and on Earth for another one. So the mass would differ based upon that. So you would divide both sides by whatever the acceleration due to gravity is.
On the moon and then on the earth?
Say again?
On the moon and then on the earth?
Yes.
So I have to find acceleration due to gravity on the earth.
Well,
I mean,
5.8.
on the moon.
Yeah, that was 1.6
Yeah.
meters per second squared.
Mm.
I will say, you would take some liberties, not the same liberties I would take. Yeah, so I cross it off in my book. Says 1 kilogram has a weight of 2.205 pounds. That really depends upon where you are. That is specific to some location, not a general rule. So that's why you didn't write an equal sign there, but still I think it's inappropriate to put it there. So that's the way Hewitt did it, but that is specific to probably some average place on Earth, wherever that is. Other questions? Brittany?
Yes, on number 10, B and C, and the maximum magnitude of force that could be acting on the box and the minimum magnitude of force that could be acting on the box.
Right?
How is that, different when we say the total and the maximum? I don't understand how they're different.
Okay, total, you're adding them together. I'm not talking, you just take the two numbers, add them, because if they're in opposite directions, you're adding a negative. If they're in the same direction, they're both the same sign. Magnitude is once you have your total. So once you've added them together, however they're added. Magnitude just means I'm now ignoring direction and just putting down what, in essence, people want to use magnitude again. For example, my weight is about 200 pounds. Technically, my weight is 200 pounds downwards, but the magnitude is just 200 pounds. The downward part is the direction piece of a vector.
Okay.
Is that sufficient?
And so, well, it says, what is the maximum magnitude of force that could be acting on the box? So if we added 24 plus 18 newtons, that's 42. If we just add them together, and so the maximum magnitude of force that could be acting on the box is the same as the total force acting on the box?
Be careful about total force, because again, total, let's erase this.
Maybe if I draw it, I'll understand it.
Let's say I have two forces, and I will draw them to some scale, whatever that happens to be. I got two forces right here. If I ask what's the total of those two forces? If they are like this, if I drew them head to tail, I would draw the first one, assume that's about the same, and then draw the second one. And so the total force, that's my total force right there in black. If instead, I have two forces like that and like that, assume they're the same length as those were. If I said what's the total there, well, I draw one of them. And then I draw the other one. I'm going to pretend I've drawn it perfectly. That's the total force. So total force depends upon, direction matters, so total force depends upon which way they're oriented relative to each other. And then magnitude would be, assuming I have some scale here, the magnitude would be reflected by how long the black line is. Is that not quite yet? All right.
Is that what we call that, the resultant?
Yes, the resultant is the sum. Resultant works for sum of any vectors.
So how do we find the minimum?
Well, how, again, that goes back to, I think the question that Mina was asking. How would you need to orient the forces so that they sort of fight against each other?
Okay. North to east, and then subtract apart.
Yeah.
So would it be 24 minus 18?
Yes. And because I said magnitude, if you did 18 minus 24, you get a negative number. Because I asked for the magnitude, the minus sign is just a directional thing, so you would just take the absolute value.
Mister, I hope you give all of us right answers, even if they're wrong.
Did I give you all right answers, even if they're
I hope you
wrong?
give us all the right answers, even if we got it wrong on this one.
At some point, after they're all handed in, I'll post the solution.
That's good, that's good.
So for the minimum, there was 24 minus 18.
Because that's when they're fighting against each other. That's when you reduce the total force.
And then for maximum, you just have them together.
Yeah, they're helping each other.
How would you type that, like, for number 5 and like future, of those type of
So,
problems?
all right, so there was I don't think I did it on the master set. Master set, I think I just said add the forces. So there's a version of that where I say, all right, so one of the forces is 2 newtons. So let's just assume that that's 2 newtons right there. What is the total force? What is the magnitude of the total force? Total force is just the sum, the resultant. The magnitude deals with what does that represent? Well, that's 2 newtons right there. And then this would be slightly less than 2 of them. So that's about 1.9 newtons. Is it exactly 1.9 newtons? Probably not. I'm doing this by eye and by finger. So if that's 2 and that's 1.9, then this would be, oops, sorry, it should be 3.9 because it's a little less than twice that. So somewhere around 5.9 newtons. Over here, if that was 2 newtons and that was, I think I said 3.9 newtons, well, that's 2. Looks like, so that would be 4, a little less than 6. I'll get about the same thing, so obviously I'm drawing something wrong. Somewhere around 5.7 newtons. So just eyeballing, once I establish one of the lengths is some particular value, then I just sort of go, well, if that's 2, then you know, how many, then I just sort of map out how long the other one is and I take a guess. An educated guess. But I'm sort of guessing what this represents if that's 2.
But you said don't use numbers.
Sorry?
You said don't use numbers.
Right.
So, I mean, you did the arrow thing, which would have been resulted.
Yes.
But I'm saying, like, how would I, because I plan to, like, turn it in tonight, but I will be home, so how would I, like, type that up?
Oh.
Like, if it was just, you know, doing the arrow thing.
If you're typing this one up, doing this one by hand just makes so much more sense. You would have to sort of, because you can, in a Word, using Word, what are you typing up on? If you're using Word, I think you can draw arrows in Word. So you would try to draw arrows that are the same length. You would end up drawing a picture.
Just attach that when I submit everything.
Say it again?
Just attach that when I submit everything.
I didn't understand the question.
What did I just say? Do I just attach that sheet when I submit everything?
Yeah, I mean, if you do it by hand and you just have that one sheet, then I would assume, I think it was number 5, get to number 5, say C sheet at the end or something like that. Then I'll look to the end and just don't make it difficult for me to find where your answer is. Or I should say, please don't. I will try to find it, but. Dina?
So for 11, A would be mass equals weight over gravity, like the formula.
Yes, I'm gonna amend one thing, though. Acceleration due to gravity. And it looked like your units were off there. Yeah, if you're finding mass, those would not be units. Units of mass. And this standard unit of mass is kilogram.
This one for 21, is this another equilibrium problem? Because it's a constant speed.
Straight line and constant speed, both. That's the,
So they're all equal?
so it is an equilibrium problem. But be careful about when you say they're all equal, that's potentially misleading wording.
What question y'all was just
The
talking
sum of the total forces, if you did it head to tail, you'd end up with some sort of quadrilateral. It's not a rectangle, it's a quadrilateral. You should end up back where you started because total force is 0. So, I'm trying to read your eyes and I'm having difficulty.
Mr. Young.
Was that the look of, oh, yeah, of course, or a look of, I have no idea the word you're using?
I've got no clue. It's just empty right now.
For an object in equilibrium, because remember when I add vectors together, if I don't end up back where I start, then my resultant is from where I begin to where I end. If it's an equilibrium, the total force is 0, so I should end up exactly where I began. In the case of the boy on the sled, if I added the forces acting on the sled, I had 42 newtons going to the right. I had whatever that normal force going up was, I think that was around 400 newtons going this way. I had 42 newtons going to the left, and then I had 2 forces acting down, and then end up back where I started. These forces equal that one, because this is a rectangle, that equals that.
Okay, so if I drew these arrows out, and if they all met up at the same place, then my answer would be equal, not,
What you would see in that, if I have, here's another example of equilibrium where it's not a rectangle. If those were 4 forces acting on an object, not a rectangle, but it's still equilibrium. This is a far more difficult case. I can't, based on the lengths of the arrows, that is less than that. That looks like the smallest force just because that's the smallest vector. But in that case, if you're going to add them together, the direction shouldn't change. So I think you've got one up at an angle and all the rest are either horizontal or vertical. Just make sure that the vectors point in the right direction when you do the addition, and you end up back at 0.
okay.
There should be only basically one setup, which should tell you relative sizes.
Okay.
Knock on wood. Yes, for Tom.
I was confused on number 21 because you said forces come in pairs. and
Yes.
It's not written that way. I was just assuming that you meant like this one would have an opposite.
Oh, the other parts, each of those forces has another one which is not shown.
Okay.
Because the weight, the opposite of the weight one, or the other part of the weight pair is acting on the ground. The other part of the friction is acting on the ground, the other part of the tension is acting on some rope out there. And I guess normal force, the other part of the normal force is acting on the ground. So I just showing it's not a complete force diagram, it's just the forces acting on that one object.
Okay.
Other questions?
So what she was just talking about, and A, B, C, D, and E, well, A, B, C, and D, we're just talking about the other force that could be acting on